Welcome to our talk, How Long Will It Take to Clean a Kitchen? And we're going to start right there. So please have a look at the picture that I put up here. Dinner's been finished. And what I want you to have a look at and to try and come up with an estimate for how long you think it would take you to clean up this kitchen. So we're looking for an estimate in hours. And just by a way of audience participation, who thinks it would take them about an hour to clean up this kitchen? 2 hours? 4 hours? 8 hours? Okay, so there's a mixture of responses in the room. But what if I pointed out that in this kitchen there's an oven, and actually as part of cleaning up the kitchen, I also want the oven to be cleaned too. And, there's a fridge and freezer, and, I'd really like that to be defrosted and cleaned as well. And I think the reality is that now I've pointed some of these things out to you, it's complicated. It depends on some of these things. So I could have been clearer about my expectations. I could have said from the start that, those things are included in what I'm thinking of in my head. But the reality is that some of those things you're actually going to need to start doing the task to even be able to answer the question how long it might take you. You need to see how much stuff's been baked into the oven, how long since it was last cleaned, how much food we've stored away in the fridge that we haven't cleaned out. And it's different, than what you thought it would be. Those of you that were saying 1 or 2 hours, I imagine your number is a lot different now. So my name's Ross Chisholm. I'm the head of embedded software at Focusrite. Presenting with me is Simon Holt, director of engineering at Focusrite, and we're going to be talking about the complexity of projects and how to forecast them. So I'm going to pass over to Simon to talk about complex versus complicated.
Great stuff. Thank you, Ross, and welcome. So, this is a talk fundamentally about forecasting. And we're going to look at some of the tools and workflows that we've tried. But I think a key aspect of this is the start point. It's important to assess where you are, to know what the right tools are to use to get to where you want to get to from a forecasting perspective. There are a number of states, perhaps, that you can be in. These are the most important two, we think, and it's important to be able to distinguish between them. So we're going to be talking about those a little bit now, because it will affect what the right tool is that you need to pick up or the right workflow that you need to deploy. So these are some of the questions that we need to answer. When is something complex? When is something complicated? And how many aspects are there to consider when you're trying to decide between those two? And are those aspects fixed, or do they vary over time, perhaps through the duration of a project or a product that you're working on? Do they stay static? So here are some of the big ones to consider. I'm sure there are others, but these are the ones that we think have the most bearing on that assessment. And of course, we think immediately in our work and in our day-to-day, perhaps about the software aspects of it. And by that, perhaps I mean web, iOS, desktop, as a software component. But then if we think actually maybe as part of that product or that project, there's a hardware component. So now we're bringing in embedded software as well. There's hardware to make and to deliver. Those things need to combine as far as the customer is concerned. It's one single product. They don't distinguish between the two. But then we need to think about team size and experience and skills. So is that a well-established team? Have they worked together for a long time? Is it new? Has it changed recently? Are there multiple teams? How are they working together? This adds to whether it is complex or complicated assessment. Engineering practices, so how established are they? Thinking about platform engineering, thinking about how you exchange knowledge, thinking about your team structures. These all have a bearing on how stable you are able to be in terms of how you forecast and how you work. And that's before we even start thinking about competition and the market that you're in. So do you have competitors? So do you have a high urgency in your time to market, which will make forecasting and predictability that much more important? Is it a very congested market? Is it a new market to you? Is it an established market to you? Are you replacing a product that already exists, or are you entering with something new? It changes the dynamic. Sales channel, if it's only software, then perhaps you can go direct to customer. Maybe you have your own web store. You can control all of those things. But if it is hardware as well, then you have to both deliver the software component, the hardware component. Maybe you have a store, login, updates to both software and firmware to be managing, and a sales channel that wants to take its cut of some of that hardware Again, it adds to that picture. And funding, perhaps how your business is structured, whether you're private or more established. All of these have a bearing on that assessment. Even if we unpack, so even if we just say, forget all that other stuff, let's just think about scope. Even if we unpack that, we need to be really careful not just to think about things as easy or hard. We still need to keep the context in mind. So let's take software only. So perhaps it's a new piece of software. You're testing it in market. You've launched it, minimum viable product, it's out there. It's still complex. You're in that, we don't know, we're testing things with customers, A/B, and that's perfectly fine. And there are plenty of well-established tools for managing your workflow and being able to forecast and release updates. But as soon as you then combine it with software and hardware, the picture starts to change. And particularly then if you consider the last slide, I know we said forget about those, but it's always in context with the business model that you have. The fundamental reality is that the answer is it depends on whether something is complex or complicated and whether that is a problem or whether you need to consider different tools in order to achieve that. So trying to create or trying to put a sort of a simple definition to try and start to distinguish between the two, we think about complicated where we know what all the parts are. So it might not be easy to put them together, that might still be hard, but we at least know what they are and we just have to figure out the right order and how to put them together. But for complex, you've got many interactions, interrelationships between those factors. You also have many unknown unknowns, so there's a level of discovery. You simply don't know everything. You know enough to get going, but you're discovering things along the way. So, quick show of hands, who has heard of, before I dive in here, who has heard of the Cynefin Framework before? Okay, a few hands. All right, so I'll spend a few moments on this then. So this is it's a framework. It's a situational decision-making framework, fundamentally, created by Dave Snowden, IBM, about 20 years ago. And it's about understanding your challenges and the context in which you're trying to make decisions. So 5 states, disorder in the middle. This is the bad state to be in. This is where you basically have no idea what's going on. So you need to try not to be in this state, and you need to spend some time thinking your way out of this box if that's ultimately where you are. But then we come down bottom left, and we'll work around clockwise. So the first one, chaotic or chaos, it sounds bad, perhaps, but it isn't. It's just the context in which you're working. So think of this area essentially as research, as innovation, as running experiments. So you're just cracking on and you're taking action. You have a hypothesis, you're taking action, and you're sensing and responding to the feedback that you get from taking that action. So you've got novel strategies emerging in that space. It's perfectly okay to be in that space. The point is it's just being aware that you are and then behaving accordingly in terms of what you're trying to achieve as a business or as an engineer in terms of what you're doing. And then moving into complex. So this is emergent strategies here. You know some things, as we said a moment ago. So there is an element of discovery. There are some unknown unknowns, but you do know some things. So this is really about placing your bets. You've got a sense of what's going on. You're holding a few of the cards, but you don't know everything. So you place your bets. You then sense the response to that. How right was I, and how do I iterate from here? And you respond accordingly. Moving further around into complicated. Okay, so now we know what all the pieces are. We know the parts. It's really a question of how best to put them together. So you're sensing the need for which parts in which order. So you've got good practices emerging here because you know what all the parts are, and it's about putting them together in a good way. And then finally, round to simple best practices. Thinking in terms of established workflows, norms, repeatability, that kind of thing. So that's a really helpful framework we have found in order to know, okay, we are here. It helps with communication, managing expectations. For the purposes of the rest of this talk, we'll focus on these two, because this is where, you can get into trouble if you think you're in one, but you're actually in the other. And we'll talk about tools and approaches that we've tried. We'll be mainly thinking about software and firmware as part of that, obviously. But it's also worth bearing in mind this is often, certainly for us, in parallel with hardware and parallel with the business. So thinking about marketing launches, thinking about other aspects within a larger company that you need to have some level of forecasting for, and where there is uncertainty. Handing back to Ross to talk us through how we've been trying to handle that.
Yeah, moving on to forecasting. So Simon's talked about complex and complicated. And let's start by looking at some of the existing methods that we've got. So here are some examples, t-shirt sizing, small, medium, large, some kind of Fibonacci-based sequence to come up with story points, or perhaps it's just a Gantt chart with a list of things that need doing and how long we think they might take. And I think the important thing to say is we're not saying any of these techniques are bad. In your context, especially in the complicated domain, actually these are probably tools that work really well in your scenario. Yeah, if they are working for you, then we're not saying that they're things that you should kind of leave. But you might find some use in the techniques that we're going to present. In the complicated domain, these probably work well, but in the complex domain, there's a likelihood that they're probably going to produce some waste as part of the process. That the unknown unknowns that Simon talked about, the fact that we need to start doing the work before we uncover it, means that trying to come up with an idea of how big the amount of work is that we're trying to do likely isn't going to be clear. One drawback is for these methods generally to work, we need to know what the total size is. In order to be able to forecast and know how we're doing, we need to know what we're aiming for. And generally, we're relying on averages. We're hoping that some things end up being simpler, some things are maybe more complex, or maybe we just overestimate the whole thing and then hope that we come down. But it's one of the disadvantages. And I think just as an aside, this is one of the teams at Focusrite. So this is a graph showing kind of story points and cycle time, the amount of time it takes to do one task. And what you'd hope to see is that over time, as story points increase, that we're also seeing cycle time increase. But actually, we find that this is more of the case with all of the teams that we look at, that story points have little to no correlation to how long something's actually going to take. The fact is that humans aren't great estimators. We're subject to biases in the environment around us, internal biases. We're either overconfident or perhaps we think it's easier than it ends up being. We don't go back and update this data afterwards, so for forecasting it's not great. But also, all of these things get amplified in the complex domain. The moment you're uncovering and the work is bigger than you thought it was going to be, all of your errors and estimation, all of the errors that you've accumulated just get worse and worse and push the forecast to be worse. And then, how do we forecast? So, we've got a number for how long, how much work we think there is. And then we start looking, okay, when might that be done? So this is a burn-up chart that we've used in some of our projects. And this blue line is tracking the team's progress over time, how many points they're achieving. And the horizontal lines on this graph are showing milestones that we're interested in forecasting towards. What you'll see in those horizontal lines is we're uncovering stuff that we didn't know about at the start. That's not a constant. That line is moving around as the team is doing the work. But we can start to build some assumptions around what that team could do. So what happens if that team slows down? What happens if they get faster? What happens if they carry on the same trajectory? And so the kind of lines coming off that are kind of presenting a cone of uncertainty we've referred to. And that starts to generate a conversation around, okay, when might that team cross that line? When might they get to that point? And that's definitely led to better conversations around, how we think about that, how we marry that up with other timelines and things that we care about. But one of the disadvantages is this, that also it needs time. So you need, approximately 5 sprints worth of velocity data before you can start to rely on that. That's quite a long time. Our sprints are typically 2 weeks, so we're waiting 10 weeks to know whether we can trust what the numbers are telling us. And we only really get a new data point every time that team completes the sprint. And then ultimately, what this isn't showing you is there's actually a probability associated to that. Every sprint, we're hoping that team carries on that trajectory. And there's a 50-50 chance as to whether they do or they don't. And then what happens? So what I'm going to now talk about is a different way of approaching the problem. So coming back to how much work is there to do? Well, if we take a project, and this is a really simple example, if we take a project and we look at the epics, the big features that we're going to implement, ideally we want all of those epics to be about the same size, plus or minus a bit, to make this work really well. But what we're going to ask the team to do is to focus on planning the work ahead of them. So they might look at the first 1 or 2 epics, really understand that work, start to break that work down. And that's really, in the complex domain, the probe, sense, respond, that's really where we're going to start getting some of the value. The team's going to start uncovering that. That's the stuff they're just about to start working on, and there's value in that. But then we can start to look at building a model. So we say, okay, in this simple example, all of these other epics, let's take an average of what we've seen that work breaking down into. So let's assume that every epic produces 3 stories. So now we can start to forecast that. We can start to work out how big the total amount of work is. And we might choose to forecast some other things. So we might be working in a legacy code base that typically produces a number of bugs every time we touch it. So we can start to build some of those things in our model. And you can make this model as complex as you want. The reality is the one that we use is a bit more complicated and has a range of work in it. I think just as a side note, it's really important in terms of the safety within teams that all of this stuff should be done in the open, that the team, we shouldn't be building this model behind the team's back, trying to forecast when they might be done. Actually, we want the teams to be involved in this process to create the psychological safety of having that open discussion. And we think that's really important. And so then coming to the next problem, how long will it take? So this is a tool that we've been using called Actionable Agile. But what we're doing is taking all of that cycle time data. So as the team are completing stories, we get a new data point every time. And then we can run Monte Carlo simulations on this. So we can take, we can do tens of thousands of simulations, run this data through, and ask this to have a stab at telling us when it's going to be finished. So coming back to the kitchen, and just to explain what this graph shows, if you were cleaning a modern kitchen where you've got self-cleaning ovens and it's very well kind of kept, you'd expect to be coming out more on the left-hand side. Actually, maybe it was easier than you thought. But let's say your kitchen's a bit older and we've stockpiled the food and we haven't cleaned anything for a while, then you're going to end up on the right-hand side. So for simple projects, you'd expect the distribution to be much tighter, a lot less variance in it. But for more complicated and complex projects, that starts to spread out. And so, we found this really useful for, again, having the conversation. So we can now talk about probability. What probability do we want to plan to? Is 50% okay? It might be in some scenarios. But actually, if you're working towards a trade show or a launch or a public launch, actually, you probably want to be working to a much higher probability. And again, this constantly gets updated in the background. So we're constantly getting new data points every time the team is finishing something. And then finally, just to jump forward a bit, actually in the last few months, we started using this tool. So this is an open source tool. Our Agile coach found and started chatting to a developer. We've worked on it with a few features, but it basically plugs straight into Jira. So what we were doing manually in Excel and in spreadsheets, this now produces probabilistic forecasts based on our epics. So it's just made the whole thing a lot easier. But I think, just to finish up, this isn't the silver bullet of this will solve all your problems. This is really about getting good data early and having the right conversations, facilitating those conversations, being kind of honest with what the data is showing us rather than kind of hunches, we found to be really useful. So I'm going to pass back to you, Simon, to wrap up.
Cool. Thanks, Ross. Good. So, last slide just with a few key takeaways. Context dependent. So it's about sensing, assessing, understanding your situation. figuring out what are the right tools for you, for that project, for the work that you're undertaking. It's important to know where you are as a start point. It's not only about forecasting. Scope is important. Whether something is easy or hard, of course, that has a bearing on it. But there are many other factors that impact how important forecasting is to you, and whether something is complex or complicated. Choosing the right tools and frameworks is important. As Ross said, no silver bullet. We're just sharing some of the ones that we've tried, the path that we've been on, where we're settling out in terms of making sure that the value of that forecasting effort is there, as opposed to just creating extra work for the teams. If you find yourself being asked or having to answer the question, how long will it take, then Actionable Agile and Lighthouse and Probabilistic forecasting are certainly worth taking a look at. So that's us. Thank you very much.